Welcome to the next Checkpoint Web video. Today we will talk about network address translation. We will create automatic and static NAT rules. We will see how traffic is getting NATed on the firewall. Also, we will discuss client-side destination NAT and server-side destination NAT. Also, we will review some network address translation related troubleshooting comments. Today we are talking about network address translations on checkpoints. Network address translation handled by separate policy, NAT policy, and there may be different types of NAT rules configured. Main different types are automatic NAT and manual NAT rules. Automatic NAT can be static NAT or hide NAT rules. For manual NAT rules, you can create a NAT rule whatever you would like to have, and you can specify exactly what should be the initial source destination and port, and what should be the translated source destination and port. It is worth mentioning that in Checkpoint we also have specific general properties related to network address translation. You can find it here, and the most important one is this one, translate destination on client side for automatic NAT rule, and translate destination on client side for manual NAT rule. What exactly does it mean? To better understand what client-side translation and server-side translation for destination IP address means, it is better to go to Secure Acknowledge on Checkpoint website and open this SK, which is SK85460. And here we have the diagram, which tells that we have a source and client, and this is called by client side, and we have security gateway, and what is closer to the destination server is called the server side. And then we have all the steps, what happened to the SYN packet from client to server when it goes through the checkpoint. Let's review this on a diagram. First, we need to agree about the traffic flow. So the traffic flow will go from the laptop, and it will go through gateway number 1, and it should arrive on WebSMS. Let's imagine that laptop has no idea how to reach to 172.16.1.100, and to make this connection happen, we need to apply some destination NAT. What destination NAT does? It replaces the destination IP address in the original packet with some new destination IP address. And to make this traffic flow successful, we need to agree on original IP addresses and translated IP addresses. Original source IP will be the IP address of our laptop. It's 192.168.43.1. Original destination IP will be the IP address which does not exist on any of the interfaces of our lab, but we will use 192.168.43.10, and then we need translated IP addresses. Translated source IP is the same as the original 192.168.43.1, and translated destination IP is the real IP address of the WebSMS.100. Having the original IP addresses and translated IP addresses, we can now discuss where this translation will happen. For this, let's make a line through the gateway, which will represent the client side and server side. This is the client side, and here is the server side. Client side and server side. So if we have a client side destination translation, then the IP address will be translated on this side of the firewall, which means that on this line it's routing happening, which means that the translation will happen before routing. So first we will replace the non-existent NAT IP address with the real IP address of the WebSMS, and only then we will route the traffic. In case if it is a server-side NAT translation, then translation will happen here after routing already happened, which means that routing should happen for the non-existent 43.10 IP address, and that's why uh, client-side translation is already preferred, because it is just less confusing for the administrator. In case if for some reason it is a server-side translation chosen in global properties, then administrator will have to account for these NAT addresses in the routing. And nobody really want to put a non-existent IP addresses in the routing. That's why by default always it is set to client-side destination, not translation. Let's go ahead and take a look how can we configure this address translation in Smart Console. In Smart Console, if you pay attention, there is no way we can configure some manual destination NAT translation with the automatic NAT rules. Because if we go to the object view and then we select our admin laptop, in NAT we can apply the automatic NAT translation, hide or static, and then we can set up the IP address, and this is the source IP address. It's not a destination IP address. So there is no point to create automatic NAT rule for destination, for translation of the destination IP address. We need to create a new rule below. That's the first NAT rule we have, and the NAT rule will be admin to SMS, and the regional source will be the IP address of our admin laptop. The regional destination in the packet should be the IP address of the SMS, but not IP address of the SMS. We need to create a new host, and it will be WAP SMS. Let's create it WAP SMS NAT. WAP SMS DNAT. IP address 192.168.43.10. Okay. Original service can be any service. Translated source will stay the same sources we have in the SYN packet. Translated destination should be the IP address of our WAP SMS on Ethernet 1. And now translated service should stay as original, and policy target should be all of our firewalls. So this exactly is matching with what we have here, because original source admin laptop, destination that's destination NAT address for WAP SMS, translated source IP the same as it was for the WAP for the admin laptop, and translated destination IP is the real IP address of the WAP SMS. We can publish this change. And now we need to go to access policy and check if this packet will be actually accepted. So we have a rule for the admin laptop to any destination and to any service with action accept means that even if we will generate a SYN packet going to 192.168.43.10, it will be accepted by the access policy. So we can install policy. Okay, close. Let's do some testing. So we didn't set up any service in the rules, means that it should work even for simple ICMP ping. Let's try to ping 192.168.43.10. And it looks like it actually doesn't work. And it doesn't work with the error message destination host unreachable, which means that admin laptop has no idea how to send a packet to the destination because it doesn't have ARP or it doesn't have a route. This is a directly connected network, and for the directly connected network, we don't need any routes. So what we are missing, for some reason, we are missing an ARP entry for the NAT IP address. To resolve this problem, we will have to add a proxy ARP on our firewalls, and proxy ARP will enforce WAP gateway to reply to the ARP request for the NAT IP address. Right now, this IP address doesn't configure on any of interfaces of the WAP gateway, and especially it is not configured on Ethernet 0, and this means that the WAP gateway has no reason to reply to these ARP messages. To resolve this problem with ARP, we need to configure Proxy ARP. Proxy ARP feature will force the firewall to reply to the Proxy ARP messages addressed to. To resolve this problem, we need to configure Proxy ARP. Proxy ARP feature will force the gateway to reply to the Proxy ARP request addressed to the NAT IP address. To configure this feature, we need to go to the SK30197, scroll down and select R77.10 and higher. And then there is an instruction for Quastrix and VRP. We have a VRP mode, but for the Quastrix, our commands basically are the same. And in the command, we need to make a note on the IP addresses that we want to use. So the IPv4 address, that's the IP address of the NAT, and this is the IP address on the client side. Then the MAC address, which is VRP MAC address, that's also the IP address on the client side, and real IPv4 address, that's the IPv4 address of our Ethernet 0 interface, and not the VRP IP address, but the real IP address of the Ethernet 0 interface, also located on the client side. And now we can go ahead and configure Proxy ARP on gateway number 1. We need to switch to Clish. In Clish, we need to add the command add ARP proxy IPv4 address and the NAT IP address. Then we can specify the interface Ethernet 0 and then real IP address 192.168.43.2. Then save config. This is the Clish configuration. It is not replicating automatically to WAP gateway number 2. So we will need to do exactly the same command, but with a different real IPv4 address on the other firewall. Again, we go to Clish, copy paste the command, but now the IP address is 43.3. If you remember the diagram, you might already tell that connectivity will not work even after the policy install. And to find out why, let's go back and review the diagram. So we see that the NAT IP address equal to the original IP address, which means that the WAP SMS will use the address 192.168.43.1 to reply to the SYN packet, and SYN-ACK will go through Ethernet 0 interface. Of course, laptop will not accept this SYN-ACK and will drop it because it will come from some IP address which laptop doesn't know, because laptop have never sent any SYN to 192.168.43.100. It only sent a SYN to 192.168.43.10, and this connection will be dropped by the laptop, will not work. So what we need to do, we need to replace the source IP address, and we should use some IP address in 172.16.1. Something. So we will use the IP address of Ethernet 1 of the firewall, and we will use not just any IP address, we will use the cluster IP address 1.1. So this will be our NAT configuration, which will allow the connectivity to work. Let's go ahead and fix our NAT configuration. In Smart Console, we need to replace the original with a cluster IP address, and we will make the NAT method as hide. Okay, Now should work. We can publish. And then we can install. Installation is successful. After the policy install, we can do another test. Let's open terminal and do ping 192.168.43.10. We see that the ping is now working. Also, we can test an SSH. And for the SSH test, we will again use 192.168.43.10. And we can successfully log in to LabSMS. In the first part of this video, we configured manual NAT rules. Now let's try to configure automatic NAT rules. To configure an automatic NAT rule, we should double click on the object, go to the NAT, check the add automatic address translation rule. Here we can select hide behind the gateway IP address or hide behind a certain IP address of our choice. Let's choose 172.16.1.10 and then we click OK. It created a hide rule, that's the hide rule with the original source of the laptop and then the translated source of the laptop, and we did not touch anything about destination service. Let's publish. And then we can install policy. Policy installation is successful. As you see, we have two NAT rules for the same original source, but this is two completely different NAT rules. And the automatic NAT rule is going first from top to bottom, so automatic NAT rule will be applied and none of other NAT rules will be applied after that. We can try making a test. Let's go to the terminal and we will make a ping one, for example 172.16.100 to get to the LabSMS. And we see that ping doesn't work because this time we really need a route. Previously, when we configured manual NAT rule, we didn't need a route. Now we can do route at 172.16.1.100 mask 255.255.255.255, and then we should specify the gateway 192.168.43.5. Okay, it requires evaluation. Let's restart with admin rights. And go ahead, add route 172.16.1.100 mask 255.255.255.255, gateway 192.168.43.5 and click enter. Now that's because we need to do route add this way. This way it's okay. Route print will show us that we have this route. Now we can do ping 72.16.1.100 and ping is successful. What exactly is happening on the firewall? We can check in the logs. In the logs, we need an ICMP. So Let's refresh. And that's a request. Double click on the log entry. We see that the round NAT rule number 1 is matched in the security policy. That's exactly our automatic rule number 1. And also we can see that that's a source IP address 1.10. It recognizes the IP address of this object, which I created before for testing. So basically, NAT is working as it is. We can do additional testing. For additional testing, we can log in to one of our firewalls. And let's do a TCP dump. The outgoing interface is Ethernet 1. And we need a host of 192.168.1.100 and ICMP. At the same time, we will open a terminal and do the ping. And we see that ping is successful. And in the output of TCP dump, we see that we are hiding behind the IP address and we are going to the SMS. And reply also is going from the SMS, going back to the IP address of our source netting. And this way the ping is successful. The other thing to check is what happens if we set up not a automatic hide rule, but static NAT. If you do like this, static, and we will leave the same IP address here. We see now it created additional NAT rule below. And this NAT rule is for the translation happening from server side to the client side. But more precisely, it will happen if the SYN packet will be originated not from the admin laptop, but for example from the WAP SMS itself. Then it will match the NAT rule number 2 and it will translate not the source but the destination. Meaning that if SMS will send the packet with a destination of 172.16.1.10, which is the static NAT IP address of our laptop, it will be translated and the new destination will be 192.168.43.1. Let's publish. And install policy. Meanwhile, policy is installing. You may ask, how come this is happening so smoothly without configuring any proxy ARP? Because what we are doing now, we are putting address .10 as our new source, and .10 is not part of any IP interface on WAP gateway number 1 or WAP gateway number 2. So why we can connect back? Why gateway replying to the ARP request address to .10? The answer to that is very simple, because when we select an automatic NAT rules, checkpoint create the proxy ARP entry automatically. If we do a WCTL ARP, now we have not one but two entries, because this one was added automatically on both firewalls. So before that, we already tested the rule number 1, which is from the laptop to the WAP SMS with the translation of the source NAT address. Now we want to translate rule number 2. This one will be from the SMS to the NAT IP address of the laptop, and then there should be a destination NAT translation happening. But before we will test that, we need to check our access policy, because it looks like we don't have any security rule to allow traffic from SMS to the admin laptop. Let's create a new firewall rule below. In this not a section below. we want a firewall rule below. We will call this rule as 2023-0302, and this will be SMS to laptop. And here we will select the source IP address. Source IP address should be SMS. SMS real IP address on the Ethernet 1. The destination, we will put an IP address of our admin laptop. And also, just in case, we will add admin laptop on Ethernet 1 IP address. Any and accept and log. This way we will see which one of these two objects is matching in the logs. We can publish and then we will install. And install policy. Policy install successful. Now we have the access rule, we have the NAT rule. Let's try to test the access. No wonders that ping will be timed out because the laptop doesn't have a access rule to allow actually the ping from SMS to the laptop itself. It will be blocked by the Windows firewall, but still we can confirm the test by doing a TCP dump on lab gateway number 1. Let's start ping. Sorry, not 43.1, but 172.16.1.10. This is the correct one. Here we do TCP dump on the interface first Ethernet 1 and host 172.16.1.10 and ICMP. We see that we receive this ping on the NAT IP address. Now I will change the interface and I will change the IP address. And we see that this traffic is going out from Ethernet 0, but there is no reply from the laptop. Let's see what we have in the logs. Okay, let's renew the logs. We have this accept ICMP traffic, this one. It is measured by rule number 2. If we click on the rule, it will show us this reverse translation. From SMS to the laptop, we see that the destination IP address 43.1 and the destination is 1.10 and source is 1.100. Means that we can change the access policy and remove this admin laptop object from the policy, and we can leave only laptop on Ethernet 1. We will leave the rule as it is, just to ensure that we will not have any troubles in future tests. The other thing we would like to check about NAT is NAT tables. During previous videos, we already checked connections table and we checked security Excel table, we checked templates, and we can also check NAT tables here. So to check a NAT table, we can do the command fw tab -t fwx alloc, and this will display all the content of the NAT table. In the NAT table, gateway tracks the protocol, that's for ICMP, that's for TCP, tracks the NAT IP address, and tracks the allocation of the source port, the original port and the translated port. For example, if we will check this one, we can do ping 0x and paste. That's our source NAT IP address here. In addition, what's very interesting, we can see NAT entries in the connection table as well. For this, we can do fw tab manage t connections minus f, which means formatted, and we can grab, for example, for source IP address for netting, let's say 172.16.1.10, and it will show us at least something, for example, like this. And here we can see that that's not server source will be 1.10. And just to make a little bit more testing, we can connect to the SMS using NAT and redo the command. It will show us now more entries, and the entries we are looking for is this one. We see that that's the connection from admin laptop to the destination of SMS by port 22, and we have the source NAT address here. And it looks like here we have also the source of our SMS and source port is 22, and the destination is our source NAT IP address for the admin laptop. That's the reverse translation. Here it's one of the source ports, and here is the same source port on the other end. Let's discuss some common NAT problems. One of the most annoying NAT problem may be the NAT port exclusion problem, when we have so intensive traffic to the same destination address from the same, let's say, source address with the same destination port, and this amount of connection exhaust our source port pool for NAT address translations. So why it is happening? It's happening because we have very limited range of source ports for hide netting, and on the checkpoint we have 50,000 source ports for the single pair of source IP, destination port. And firewall will cycle through the available source ports, but at some point it may happen that we have too many connections and we don't have enough source ports. In this scenario, traffic will be dropped. And before R81.10 and before R80.40, that was a pretty common problem. With R8040 global NAT table was introduced, and this was a big change. To review what happened, we can check the SK number 165153. This discuss the GNAT table and what is the difference. Basically, the difference is that before global NAT table, each firewall instance had only very limited pool of source ports, and let's say if we have 12 FW workers, each worker will have only 4,133 port range. And for very intensive connections, for example, to a proxy server or from a proxy server to some destination server in the internet, this certainly may not be enough. With a global NAT table, every firewall instance can access the global pool of source ports, and if the port is free, it will be able to use it. The other common problem with NAT tables is NAT port reuse. NAT port reuse may happen in case if we have some connection going through the firewall, and at some point, for example, we have a destination, and that's the connection to the destination server, and this connection was closed. Meanwhile, the destination server still has the entry in the server connections, and this entry will have source IP. It has a destination IP of the connection, which is the server itself. It has a source port, and also it has a destination port. In case if we have NAT implemented on the firewall, this source port will be port from NAT pool. And in case if this connection is already completed from the source perspective, it may still be in a destination table. And when a new connection come in and go through the same gateway, then it arrives on the server, and on the server it will have exactly the same source IP, exactly the same destination IP, same destination port. Sorry, that's destination port. Destination port, and it will have also the same source port. And this source port will match the previous connection, and for this connection the server will not wait for the new scene. Instead, it may wait for something else, for example, for FINAC or some other FIN packet. In this case, server will drop this scene, will not establish a new connection until this entry is expired. Only when this entry is expired, this connection can be established successfully. For resolution of this problem, on checkpoint, there is a timer for how long firewall will keep an entry in the NAT table before the source port can be reused again. And this entry should be kept long enough so the port will not be reused long enough for the destination server to clean up connection table on its end and allow the connection to be established. So you may ask, how would we troubleshoot NAT-related problems? There is an SK on checkpoint, and this is SK60343. And even here there is a flowchart, not troubleshooting flowchart, but the whole idea of this flowchart boils down to some commands. The first command is to check how many NAT entries do we have in the NAT table. I mean, how many entries we actually can have in the NAT table, and we can check it with the fw tab minus t fwx alloc minus s and grep limit. Limit is 25,000 entries, and right now we have 7. So we are nowhere near of exhaustion of the size of our NAT table. Also, we can check NAT cache size. NAT cache size is also very small. It has 13 entries, and in the peak we had 23. So very low numbers. Additional NAT information can be checked if in fwctl pstat. And this is the NAT-related section of this command. Basically, here we can see in real time if we, let's say, have some additional NAT allocations happening. We can do watch minus n1 minus d and the command of fwctl pstat. And if we will start ping using the NAT port 172.16.1.100, we see that the numbers start increasing. And we stop ping, the numbers are not increasing anymore. Here we can also monitor some NAT-related numbers. The other thing to check when you have a NAT problem is to ensure that you have all the necessary proxy ARP configured. Especially if you do not use automatic NAT and you use only manual NAT, you need to do fwctl ARP, and it will show all the proxy ARP addresses that you have configured. The other way to do it is in Clish. You can do show ARP proxy all, and as well you have the IP addresses that you configured manually. And the first entry here is the IP address which was added automatically. The theme of NAT troubleshooting is very interesting, and it's very creative. And to have the full understanding of how to troubleshoot NAT, it's better to go through basic NAT-related checkpoint case. I will refer these secure knowledge articles in the video description. And in case if nothing helps and you have no idea why exactly NAT doesn't work, the next step would be performing a NAT-related debugs. To get the exact NAT debug that you want, it's better to go through the SK and select the debug you want to do based on the problem you have, because to analyze the debugs is quite a long process, and it's not a good idea to have the whole debug analyzed in the YouTube video. Also, checkpoint tag can recommend the exact debug you want to do for your particular problem. One of the troubleshooting steps to do if you have NAT problem and you do not afraid to clean up the NAT table, you can do it very easily with FW tab. You can do FWX alloc -X to clean up the whole NAT table. -T, like this. And yes, for example, I want to clean up the NAT table, and also I can clean the cache, NAT cache. Yes, I want to clean up NAT cache table. So these two commands may help you if you have, let's say, some maintenance window to clean up the tables and let all the applications you have in your network to reestablish connections through the gateway. This is the end of today's Checkpoint Lab video about network address translation. Thank you for watching.